Hi everybody, welcome to the DevNation Tech Talk for August, as it's just still about August. Got some fantastic people today to talk about Quarkus and test containers, which I've never heard of, so I'm going to have a lot of fun listening to this. I'd like to pass it over initially to Eric to give a quick intro, and then on to Oleg. So go for it.
Yeah, thanks, Uth. So I'm Eric D'Andrea. I am a Red Hatter, as you can tell from, hopefully I'm pointing to the right thing over here. It's hard with virtual backgrounds, but I work for Red Hat. I'm a developer advocate at Red Hat. I do a lot of talks and talk about Quarkus and whatnot. And so I'm privileged to be here with Oleg. And I'm not going to even attempt to pronounce your last name with that little squiggly thing over an S, which looks completely foreign to us Americans over here. So kick it over to Oleg.
Thank you. Thank you, Eric. Hi, my name is Alex Shalaev, and I work as a developer advocate for Atomic Jar, which is a small startup maintaining test containers libraries. That's how I got here, and this would be like a part of our chat today, test containers libraries.
Sweet. So what are we going to talk about? So I know we've actually been working on this for quite some time. It was an idea that was floated. What was April, May is when we first started talking about doing something like this. And then the summer came and everybody goes on vacation. Most of Europe disappears for the whole month of August. So we wanted to talk a little bit about Quarkus and test containers and kind of the synergy between them, because, under the covers, there's a huge synergy, and they're both important to each other. And, I don't think, Quarkus could be where it is today without test containers under the covers. So let's talk a little bit about it.
Right. Thank you. That is like a very, very generous statement. Quarkus is an amazing application framework. I think personally, I feel it's very, what's a good adjective? Like, it's very neat. It makes some fundamental decisions about the functionality it wants to offer to the users, and then sticks to them. And together it comes with a very nice package, and test containers powers just a part of that. So, but I'm happy to hear that you feel it's an important part. Shall we maybe start with a little bit of test containers intro, so everyone is more on the same page about what the libraries are offering, and then go and see how it helps Quarkus?
Yeah, sounds good.
Perfect. So just a very quick intro, and I want to keep it a little bit more live. So a few slides with basic information, and then a little demo so we get a feel what test containers offers. Test containers libraries are open source libraries, and they are available in multiple languages. So popular languages like Java, Go, .NET, and Python, and Ruby, and Node.js are supported. And we're going to obviously look at the Java implementation currently. But what they give you the API to programmatically manage, configure, and use containers and services in containers. And because it's in your programming language, the natural place for that is in your application lifecycle code or in your tests. So your code actually can create the whole environment with everything that you need for your application to run in very, very easily, straight from the code, without depending on anything else. And test containers gives you the low-level API where you can, as a developer, you can just write, I want to run Redis, or I want to run some other technology. And test containers will download the Docker image from a registry and then configure it properly, manage the lifecycle for you, and give you the whole full control over what you want to do. And then on top of that, there's the whole ecosystem of test containers modules, where there's a predefined abstractions that that allow you to configure popular services, like most of the databases, message brokers, cloud emulators, and so on, in just a few lines of code. So you can run anything in Docker container. You can run your custom in-house things, but also I'm going to show just in the demo, how easy it is to run, for example, like a database. So to get more information about that, just go to testcontainers.com and you can find out how to get started with that in other languages as well. But here's a little look and feel how it works. So here's my normal Java project. It doesn't have any framework on. It's a Maven project. So I have added my test containers libraries to the dependency section, right? So we pull the test containers JUnit integration from Maven Central, and we pull a few modules that I could use independently. So it's not like I'm pulling the whole ecosystem of modules at once, but we pull the core, and then there's just, we want to run Postgres, we want to run Kafka, we want to run local stack. And now, given those things, what I can do in my code, what I can say, give me a generic container, all right, and then let's say we want to reproduce that example where we run Redis. We can say new generic container and say Redis. Content that just doesn't work for some reason, but we can say generic container Redis Alpine. Now, this is a normal Java object. When test containers is gonna run, it's gonna start executing whatever the configuration we want. So immediately what we can do, we can do anything we want to do with a Docker container, but we can do that programmatically. We have the lifecycle methods like start and stop, and we would like to start it, of course. We also have on the actual, with a Fluent Builder API, we have the configured configuration options. We can, for example, expose ports. Redis is a online thing, like it's a network thing, right? We're going to use it through network calls. So we need to expose the port, which is for Redis is the 6379. Notice how I don't specify which port to map it to. Test containers is sophisticated enough to know that, well, you cannot map to the same port, right? Like you cannot map to the port 6379 on the host machine, because like if I would like to run two Redises, like there would be a conflict and nothing would work. So we map to random high-level port, and then you configure your application by querying that from the same Redis object. And you can configure anything, right? You can configure the networks. If you want to build complex topologies, you can configure the dependencies between containers if your lifecycle requires that. You can override the commands for the particular image if you want to start it with the additional parameters, for example, to speed it up for testing. You can copy files to containers, anything you want, environment variables, the whole configuration options for that. But we don't need to do actually anything else. We can just do start the Redis and then, for example, assert that Redis is running. Right? This is my first test, and I can already run it. So when I click run the test, what happens is the test containers libraries are figuring out find the Docker environment that they deal with, and then they pull if necessary, pull the image from the registry, start the image. You can see the container was starting, and then my test actually runs because we know that it is actually was started. So this is a very, very simple, basic example. If I want,
does it clean up the containers if you don't remember to put Redis.stop?
Yeah. So the lifecycle is managed automatically by test containers. So after running the test, I can say that, oh, look, there are no Docker containers running. And yeah, that's it. So I want to show another thing, but I will not type it all just now, just to save a little bit of time. So, but I want to show you the modules as well, right? So you can run and configure this, but this is maybe a little bit awkward if you don't know how to run, for example, Kafka. Eric, do you know how to run Kafka in a Docker container?
If I could probably Google it and tell you in about 15 seconds.
Oh, I think it's a little bit more complicated than 15 seconds, but for some technologies, you can just say new Kafka container, right? So like, and that class will come from the library that we put on the class path. So somebody who actually knows how to run that puts this information in the library. So, but what I want to show like a little thing called configuration. So if you run Postgres, if you want to run Postgres, how do we configure it? We can say copy file to container, and we copy the schema SQL file to some configuration path that we know Postgres image looks at when it starts container. And we can do the same things, and we use the same assertion where it's running. We use the convenience API. This is the other point why modules are so good, is because they can expose the methods that you would like to use, and you don't need to create them manually yourself. And then we can, for example, stop the container. So I can run this test, and then my database will actually be populated with the predefined schema and work with it. Now, the container will be stopped and cleaned up. And now the only thing this test requires to run is the Docker compatible environment. You can run it with your Docker desktop, or you can run it with your normal Docker daemon. And that allows it to run the same way on CI in your local development environment.
Or even Podman.
Yeah, it would work with Podman. It would work with Colima. It would work with Orb Stack. It would work with what else there is? A Minikube cluster exposing the Docker API if you configure it correctly. And one thing that Atomic Jar also offers, and this is a very recent announcement, so this is like the fresh piece of news. We recently announced and created the Testcontainers desktop application. It's a free application that can help you. It sits in the menu like that, and it can help you with your Testcontainers-based tests. There are a couple of development features, developer-oriented features that I want to show. So I can use that application to switch where I want to run my containers, Docker desktop, Orb Stack, or even in the cloud, which is a service by Atomic Jar. So you can rely on the cloud to run containers. But I want to show you the debug mode here, right? So I run my test. I can say freeze container shutdown with just a click of a button. And then my test will not finish. The containers will refuse to die. So I can debug it. And there is an abstraction called services for the Testcontainers desktop, which is where I can configure. Remember how the ports were dynamic, right? It's a little bit awkward to connect your local tools to that. So with Testcontainers desktop, I can say, for anything that runs Postgres via Testcontainers, please proxy the local port and give the local port to the container port in that particular container. So with that, my local tools can use the Postgres container running inside my test as if it was my local Postgres. So
because you can see there it's running on port 32 something or other, and every time you run it, it's going to be a different port, right?
Yes. So this port, which is Postgres, actually like binds to it, like the exposes the corresponding Docker port is a random 32,000 something port. But now with the thing, I can say my database, come here, database tool. I already have it here. I can configure my tooling, for example, my ID to use the fixed port, and the fixed port will be proxied, and I can inspect my things, and I can see my data in the containers, or if that is my, I don't know, the Kafka, I can see my messages and topics in configuration, or if there's anything else, I can work with the containers as if they're running locally. So, and after I'm done debugging everything, I can say like release the containers, and you will see that my test finishes after that very quickly. So it's just a little helper. If you're running test containers, check it out. It's a free application, testcontainers.com/desktop. And I hope you will like it. So this is approximately what it feels to work with the test containers-based setups. You write some code and you get containers that you can use in your application tests very, very naturally. So how does Quarkus use this?
Yeah, so that's a good question. So Uth, if you wouldn't mind switching our screen shares over. Here we go. So take kind of what Oleg said and kind of keep that in the back of your mind. So what I'm going to do is I'm going to create something completely from scratch here. So it doesn't look like I've got like some voodoo magic. Although I will do some magic because, like you said, people don't want to just stand around and watch us type stuff that's not completely important. So I'm using IntelliJ. I don't know how visible it is, but I'm going to go through and I'm just going to create a new application from scratch. So we're going to build our favorite demo application that everybody in the world uses, our to-do management application, right? So I need a REST endpoint. I need we're going to use Postgres. So I need a JDBC driver for Postgres. I need Hibernate because we want to do persistence. I'm going to, I prefer YAML for configuration. I like YAML over flat properties files, but that's just kind of personal preference. We are going to add eventually some new enhancements to this application. So we're going to kind of show some of the lifecycle. So I'm bringing in the REST client so that my application can make REST calls to other applications. I'm going to bring in the Open API extension because we always love Swagger UI. And I'm going to bring in the health check because it's just something you should always do out of habit, right? Your application should expose health checks. So once I have that, I'm going to click create. And my guess is that it just opened up in a different monitor here. So now I bring this in. And one little piece of magic that I'm going to do, because I've kind of already got some sample stuff already built. Once my terminal comes up, I'm just going to run this little script that I put together, which is going to kind of bring in some starter code for me. So if we look at our POM, we've got a pretty standard Quarkus application. I've got the REST Easy, which is the JAX-RS implementation. I've got Open API, my YAML extension, all the stuff that I just built. And one thing you'll notice here that there's this WireMock test containers library that we'll talk about in a little bit. But other than that, there's nothing related to test containers in here. And so you might start to wonder, well, this whole talk is about the synergy between them. Well, where is it? And it's actually buried inside Quarkus itself. So Quarkus has this really nice abstraction on top of test containers, and it uses test containers under the covers without you, the developer, having to do a whole lot of stuff. And so I'll show that in a second. But just to kind of show you the rest of the code here, there's a tool window. So I've got a little imported SQL file, kind of like you showed before, where to be able to insert new data. I've got just a very basic user interface, which I'll show in a second. And I've got some domain models. I've got a JPA or Jakarta persistence entity class in here. I've got a repository class for interacting with it. And I've got a pretty simple REST API that's already been built. So finding all your to-dos, finding specific to-dos, updating existing ones, creating new ones, deleting ones. And then I've got this kind of stub that we built out. So we're going to do two things. If I run this application, so I'm going to say Quarkus dev clean. It's going to run the application in dev mode and wait for that thing to come up here. So you notice the first thing that happens once it finishes, I probably should have had Maven download the internet before we went live. It's pulling some images. And so it should actually, here's this. One interesting thing is this dev services for the default data source Postgres has started. So I had already talked about that there's no test containers binary or whatnot in our own pom.xml. But if I open another terminal here and I do like a Docker PS, well, the first thing you're going to notice is I'm not even running a Docker host. So I'm actually taking advantage of that little test containers desktop utility that Oleg was talking about. So these containers aren't actually even running on my local machine. If I hit the D key, what's called the dev UI, and of course that popped up on a different browser window. So if I drag that in here, so Quarkus, when you run it in its dev mode, comes with this little utility that's baked in for being able to do all kinds of development stuff. And one of them is what we call dev services. So you can see here, there's actually a Postgres database running. Here's the URL, kind of like you said, 32.769, but I've got that little services thing as well. So I could actually interact with it on localhost 5432, even though this database is actually running in the test containers cloud. So if I click on this little, open dashboard here, it's going to come into the test containers cloud, and you can see in my current session, I have a Postgres 14 database that got started 2 minutes ago, and it's part of my current live session. So I don't know if there's anything in here you want to talk about, Oleg, but
these are the web application offers a couple of collaborative dashboards. So you can, if you look at the latest session, you can maybe notice some unusual patterns for the containers that you don't maybe want during your test. For example, if you spin too many individual containers, you will see like a ton of rows with just a little bit of a life cycle. And maybe that can trigger something like, oh, maybe I can speed it up or see it differently. And the common Docker images, we will be adding more information in there to make them more useful, but you can already see some things. For example, oh, you're running Postgres 14. I think 15 is the latest stable, so maybe you need to upgrade or stuff like that. It's just a helpful like insight into what containers you've been running in your tests.
Yep. Yeah, so it's kind of cool. Like you said, you see that it's running 14, and because I created this app from scratch, Quarkus is just giving me defaults. It says, "Hey, you've got a JD. It looks like you've got a Postgres extension present. You haven't told me what to do with it. Why don't I just go pull one that I think would be the best one for what you're looking to do, but allowing you to configure it."
I actually don't know if 15 is the latest like stable, or if it's just
I don't know either.
a part of a different release. So not trying to throw shade on the defaults Quarkus offers, just something that you can notice.
Yeah, and the other thing that's in here, you can see I've got this little health check thing. So it's already, because I have the health extension, it's already kind of pre-wired and says that, hey, your database is up and working and everything is good. I've got somewhere in here is the Swagger UI where I could go interact with my application. Yeah, right here. So I could, look at my to-dos. But what might be better is, actually interacting with the application itself. So like I said, and of course it opens on a different browser tab on a different monitor. You think it would know where I want to be. So like everything, we've got this nice to-do application with this nice little UI. I'd love to go on vacation. I can complete the to-do. I can delete the to-do. So it's pretty simple application, but it's all persisted in a database behind the scenes. And I actually haven't written any code to stand up any databases or anything like that. It's all stuff that Quarkus is doing for me. So that's kind of cool. Another interesting thing, we talked about, or you kind of started to talk about, like things like Kafka. So there are times where, like if I was running multiple applications and I was using like a database, each application probably has its own database instance and you're not sharing. But when you're doing event-driven applications and you've got like messaging from one app to another, you probably want something that where if I want to run them locally, especially locally, that it's going to share the resources, right? If one app puts the message on a messaging broker, the other app should be able to read it. They shouldn't kind of have their own standalone instances of that. And that's something Quarkus gives you kind of out of the box. So let's enhance this a little bit. So one thing we want to do is when we complete a to-do, it's like if I, go on vacation, if I, check it off that it's something that I've done, one thing I want to do is like, well, maybe there might be other things that might be interested in doing something or knowing that I completed a to-do. And rather than, adding new capability into this application, maybe I want another application. So, one way to do that would be, write it to, some kind of message log that other things can then just start to do stuff with. So what I'm going to do, so I'm not even going to stop my application. It's still running in its dev mode. But what I'm going to do is I'm going to say, I'm going to add the Kafka extension to my application while it's actually running. And if I switch back to my console, you see it's actually going to bounce my application. It's going to probably start to error out because I haven't done anything with it yet. And then what I'm going to do is in my resource class, you see it's starting to error out because it doesn't know what to do with what I just did. I'm going to add in what's called an emitter. And this is I'm going to just reuse, you probably wouldn't do this. I'm reusing the JPA entity through my REST endpoints and through my Kafka. You probably wouldn't do that, but this is live demo, and that's what we always do. We build single class applications in live demos, right? So I'm going to do this, and I'm going to call this my entity emitter, and then I'm going to have IntelliJ added as a constructor parameter, and then I have to bind this to a channel, and I'm going to call it my to-do completion. So when I save that, now everything is kind of happy. So now if I come down here to where I say, okay, now, when I do a completion, I want to send it to a Kafka topic. What I'm going to do is just say anyemitter.send, and I'm going to send my to-do to the topic, right? So now if I go back to my application and I reload my application, it kind of comes back, with a fresh start. What's kind of cool is I could actually, if I wanted to like modify my JPA entity as well, it would actually rebuild my database and my database schema on the fly as I was coding, and I wouldn't have to type anything or do anything. So if I, do go on vacation and I complete it, what actually happened? So you can see in the logs here that it completed, But if I come back to my dev UI now, right? Oops. If I come back to my dev UI, you notice there's like a box here for pretty much all the different things that I have. And one of these boxes is this Apache Kafka client. So different extensions that you add to your project can add things to this dev UI as well. And one of these things is topic. So if I click on the topic, I can see now I have a Kafka topic that's got one message in one partition. And if I click on this, I can actually visualize the data right in my Kafka topic. So I can see here's the JSON payload that was put in. Go on vacation, it was completed as true, and here's the timestamp. So I didn't have to like do anything. One thing people say, like when you start debugging things, is how do I know, especially with Kafka, like there's Kaf drop, or there's a bunch of open source tools that you can run and connect to a Kafka cluster to visualize. But this is kind of just out of the box as a developer. I haven't really had to do anything.
Yeah, this is very, very cool. If you were like not very experienced with Quarkus, the extension system is absolutely brilliant, because you type this one line of code, right? Like add what was it, like Kafka messaging, or just like one thing, right? Reactive messaging Kafka, and it added the necessary dependencies, right? It reloaded the project so you can use them in your IDE normally fully, and then it added this extension UI, and it added hopefully the integration was, well, it did, right? Added the integration with Testcontainers Kafka module, or I think it's Quarkus by default runs Red Panda Kafka API compatible message broker, and then the whole package is there. And as a developer, you just think about, oh, I need Kafka. You add the extension, and it's all there for you. Brilliant.
Yeah, you can see if I come back to the Dev Services tab, you can see there's my Postgres database, and then there's my Kafka, single node Kafka broker that's running. And again, I've got the little widget here installed, so I could look at it on 9092 because it's remapped to my local port. But kind of what we talked about was, okay, now how do you actually share that? So if I actually have another little application that I've already written. I'm not going to build it from scratch, but it's literally a single class application that just listens on that topic and just does a log message. It's it's very, very uncomplicated. But if I run this in the dev mode as well, this Quarkus application, you'll see that it's actually not going to start a new Kafka instance. It's not going to pull a container because it sees that, hey, I've already got another Quarkus app that's running and it's already started a broker. So now it's actually bound this instance or this application to the same Kafka broker that my other application. And you can see it's actually, because it started up and because of the way Kafka works and consumer groups and offsets work, is it actually saw that there was a message there and it pulled it because it logged the message that was there on the topic. So now if I go back.
Does that mean that the dev UI extension, like it registers as a separate like consumer group or something, so it doesn't steal the messages, right? It just observes the messages. That's cool.
Yeah, so this registers as its own consumer group. So the Kafka dev UI can have different consumer offsets than any other consumers of the Kafka broker, which is kind of cool.
It'd be awkward if a dev UI would steal messages and then you would not expect. That was the silly question maybe, but that's cool.
So now if I go back and I say, I want to, as a to-do, I want to eat lots of pizza. I like pizza. And then I complete that. If I come back to my message, you can see it's flowing through and it logged out that I ate lots of pizza. So now I've got two applications that are running and they're sharing the same infrastructure. And if I go back to my, the Testcontainers cloud thing, where did that open up here? Now you can see I've actually got two container instances. And actually, what's kind of cool about this is it shows that this one actually stopped. When I added the Kafka extension and it bounced my application, it actually stopped this instance and started a new one. And then it started the Kafka instance, a couple of seconds later.
Yeah.
So it's kind of cool. So this kind of what Quarkus calls dev services, there's a whole bunch of them that just come out of the box. So we've demonstrated Postgres, and we kind of lump that into JDBC in general. It supports pretty much any kind of JDBC database, whether it's MySQL or MariaDB, Postgres, Oracle, SQL Server, those kinds of things. But there's also a whole bunch that just kind of like it's the same thing, just come out of the box. You've got AMQP Broker, Apicurio for Avro and Protobuf Registry, Kafka, Keycloak, even Cube. If you're building applications that use the Cube API, there's a dev service that can emulate the Cube API for you when you're doing live coding. So the other kind of differentiator here, what you talked about, with test containers, what you showed was mostly running, when you run your tests. This is actually, now we've taken it a step further when you're actually running your application live in a live dev coding mode, where you're harnessing the power, using the power of test containers. And I say we all the time. I actually have nothing to do with it.
Yeah, this is the dev service is a part of the Quarkus application lifecycle. Technically, any project could implement something similar using, well, for your particular project, you can implement it for your set of dependencies that you want to run just using the Testcontainers API. It might be not the most trivial task, but it's doable. And I think, it's not even just Java dependent. I think we recently published a blog post how to do a similar thing in Golang. But yeah, it's very good that Quarkus has this out of the box. And then that makes it very, very easy. And what is really, really good about this is that your whole team gets the same experience, no matter what you're running on, right? Like whether it's a new person coming in, if you need to work with the Quarkus application, you clone it, you run it, and the whole environment is there. Yep. There is no forgetting to run like a MongoDB instance or messing up like a compose file or something like this. It's just
because I've been there too. Like we're using Docker Compose, you've got this compose file which sits at the root of your repository, and you make changes to your app, and then you get drift because you forget to update something or update a version or something, and now you're even within your own project, you're already kind of out of sync, and never mind starting to share amongst other teams.
Yes, and then it also awkwardly doesn't work very well with sharing the services among different projects unless they are like submodules somehow easily. So there are a number of advantages to having the programmatic API, and this flexibility is probably the biggest. No, it's very, very good. I like this very much.
Yeah, so let's look at some. So this list is pretty extensive, but let's think about something. How could we use test containers to do something where it wasn't just kind of out of the box like this?
Yeah, like so how the integration runs and how you can enhance that if you want to configure some other containers to run.
Yeah. So the example I think we came up with is, well, we started throwing ideas like, well, could we create a GitHub issue or something like that? And I kind of thought about it. I was like, well, why don't we just tweet? Everybody tweets everything. So like when I complete a to-do, why don't we just send it to Twitter and tweet about it? So I don't see on this list, there isn't a Twitter thing. And I don't think Testcontainers has a Twitter module.
No. And in general, the third-party services, which is not like sort of stock applications like a database, right? But the service, I think our usual recommendation is to mock it on the service level with different technologies. Like you can use WireMock, or you can use mock server, or I think maybe you can use Microx. Not 100% sure, but I've heard that about that project recently, and I'm planning to look into that. So yeah, can we maybe mock Twitter? And then,
so you mentioned WireMock, and I've personally used WireMock before, both as a Java API. You could use it, in Java code, work with it, and set up stubs and whatnot. But there's also a WireMock module. So you're talking about, with test containers, there's all these different abstractions for different things. So you've got like Postgres container, Kafka container, and so on. So there's third party. This is third party, right? You guys.
This is a cool thing. There is a little ribbon you see next to the name, and there is it means that this is part of the official modules set, which is a cool thing. Now Testcontainers has Atomic Jar as the entity behind it. So now we're not just an open source project, but we can do sort of company to company communications. And one of the initiatives that we are running currently is called official modules. This is where the engineering team of Atomic Jar, we know how to run tests, what it means to be a good test containers module, what makes a good integration testing experience. We partner with the vendors of technologies, and the official modules are a result of that collaboration between the teams. So for this WireMock module, both the Testcontainers team looked at it and also the team at WireMock. So we bring in the expertise about testing, about how to write integration tests or the particular module, and they bring in the expertise about the technology. So what WireMock should be able to do, right? So in the same way as when you configure Postgres, you want to have convenience API for getting JDBC URL, right? Or when you run Kafka, you want to have convenience API to get Bootstrap servers or enable Zookeeper or disable Zookeeper. So that information is there are hundreds of technologies. So it's really hard for the test containers maintainers to know all of them, but that's where the partnerships come in so handy, because the vendor engineering team knows exactly what are the features, what are the cool features, how to enable them in the best way, and they contribute that. So the WireMock module is the collaboration of that. The ones that are not official mostly started either by the Testcontainers team or by just the community contribution.
Yeah, so you can see I clicked on the module. There's lots.
Yeah,
I'm not gonna count
I think
them,
there are more than 50, I think, here currently. Not all of them. Some of them are in the Testcontainers repos. Some of them are in the third-party repositories, but they're all in a decent shape. There are people who use them, but yeah.
So kind of one thing that's interesting about WireMock, though, is if you go to the WireMock site, so I kind of went from here to the WireMock documentation here, but they have, so when I first looked at this, and it took you to point this out to me, there's 4, 8, 9, 10, there's 11 what they call featured, and one of them right here is the Twitter API, which is what we'll go look at in a second. But it took you to tell me that if you click on all, I mean, there's 2,300
yes,
templates in the WireMock template library. So pretty much, I'd say if you're looking to mock or stub something that's HTTP based, I think does WireMock do gRPC too? I don't remember. I don't know.
We will need to check.
Yeah, I have to check. But essentially, if you're looking to do REST and talk to something, there's probably a WireMock API template or stub there that's already been built for you. So if we come back and we look at the Twitter API, for example, what I can do is I can just download this
JSON file.
This JSON, it's actually a pretty big JSON file. So if I do, where's save as here? Where's my save as? Save link as. Yeah. All right. So if I come in here, and of course it doesn't know where I am. Where did I decide to save it? In here, I'll come into my app. I'll go into source, test, resources, WireMock. And it doesn't really matter where you choose. Somewhere under source, test, resources, I just created a folder called WireMock, and I'm going to save that in there. And so now if I come back to my IDE and I look in source, test, resources, WireMock, I have that thing. And
how many lines?
Yeah, how many lines? It's pretty massive. It's got the entire Twitter API, so it's 4,500 lines. So rather than look through that, what I decided to do, so I went to the Twitter developer API guide, and I found, because all I want to do is post a tweet, so I really only care about one operation, right? I don't need the entire Twitter API. So I looked at, okay, what is the API for actually creating a tweet? And so it's a post to this /2/tweets. If you read the documentation, with there's the example response request body has a text attribute with the text, and then the response kind of looks like this. So I'm going to come back and I'm just going to delete this whole thing, and I'm just going to paste in so you don't have to watch me search everything here.
Right. So
here.
Normally, like if you use one of those templates, you probably you can like search for the operations in there and like get the slice of that stub that you want to use. But because it's a sample demo application, it's easier because that operation was already done.
Yeah.
Okay,
and
so what do we
I
have?
changed the sample text too to just go. I like to go on vacation. If you haven't been able to tell, I like going on vacation. And I took actually a lot of vacation in August. I was gone more than I was here in
Right.
August. So I've just narrowed it down just to that one
Operation.
single operation here. And so what I can do with Quarkus now is I can create what's called a lifecycle manager. So because Quarkus under the covers has hooks to be able to manage the lifecycle of these different containers. It also exposes a way for me to create my own, because this isn't something that comes out of the box. So I'm just going to call it a WireMock resource test lifecycle manager, right? And rather than have me write all the code, I'm just going to kind of paste it in here. So we implement something that's part of the Quarkus test framework, this test resource lifecycle manager. And basically that gives us hooks for starting and stopping services. And Quarkus will manage the lifecycle of this. It'll start it when my tests start, and it'll stop it when my tests are done. And by default, it'll only start it once, and it'll stop it at the end. So all of my tests will share the same instance, which I can, override on a per test basis if I want to. So essentially, I'm going to use the kind of like you said, the abstraction, this WireMock container object. I'm going to give it the image name, and I'm going to point it, kind of where that resource file is. So I don't need to know anything about the container. I don't need to know how to configure the container, because it exposes this nice, hey, I've got a class path resource which has the stub file. Just add that to my container, and it takes care of the internals. So I can start it, but then I can also tell my application, because if I'm going to build a REST client, it probably needs to know what the URL is, because now it'll have this little container that's running beside my application on some port that I don't know. How do I expose that to my application? And I basically return a map of properties that I want to expose to my application when it's talking to these things.
Right.
So now that I have that, we can actually go build our client that's actually going to talk to Twitter, which is, you might think is complicated. It's actually pretty simple. So I can call it I'll call it the Twitter client. And again, rather than have me write everything out, this is just a simple JAX-RS or microprofile way of writing REST client. So I don't even actually have to write the implementation. I just build an interface. I'll come back to the object in a second that, I'm calling a send tweet. It's a post to that path that produces and consumes JSON. And then I created Java records, which represent the, remember from the documentation, what does the request body look like? What does the response body look like? So we can just create some records that look like that.
Yeah.
So now
that's super neat. Like if you are watching, if you're still on, like, say, Java 8, like, what are you doing? Please upgrade.
Yeah. And of course, I put everything in the same class because we're doing a demo and I don't like flipping between code. Normally, I would probably create these as their own records in their own files somewhere, but we're doing demos here. And then, of course, we have to write tests, right? Because there's no tests here. So I can say, have IntelliJ. It's one reason why I love IntelliJ is it throws testing right in your face all the time. It's like, hey, you don't have any tests for this. You don't have any tests for this. So now that I have a test class, like, again, I'll call rather than have me write all my code, I've created a Quarkus test. I'll come back to that other annotation in a second. I've injected the Twitter client into my test, and then I have a test that's going to, call the methods. I'm going to send a tweet. It's going to get a response, and then it's going to assert that, the text is equal to go on vacation. And then this kind of one line annotation is what binds or ties that resource manager to this test. So it knows now that this test, when I actually call this Twitter client, it is going to make a live HTTP call, except it's going to make an HTTP call to the WireMock container that's running beside my application.
Right. Well, the test itself, right? Correct me if I'm wrong. The test itself doesn't know that it runs against the WireMock container, but that WireMock resource test lifecycle manager starts the container and it overrides like that map of properties, right? It overrides whatever configuration I have with that dynamic one, right? So the manager wires the application with container.
Yeah, and you notice as soon as I saved this file, like on the console here, Quarkus has this continuous testing feature. It noticed that I had, before it said no test found because I didn't have any tests. As soon as I saved this file, it recognized that, hey, you've got a test I need to run, and it actually ran and verified my test. So like I could go in here and I could, modify my test if I wanted. And as soon as I save it, it's going to rerun my test in the background, and it's going to tell me that it failed. So you kind of get this immediate feedback. And this would hold true. I don't have any other tests written, but it would hold true if I made changes to my other code. If I had tests for my other code and I made changes, it would rerun just the tests that are affected by that code change in the background, automatically for me.
Is it still running that like Quarkus dev mode that you did like an hour ago?
Yeah. So the application is actually still running if I come back here. Yeah, and it bounced it a few times when I did stuff, so because it resets the database. But I could have turned on that freeze container shutdown, and it would actually have reused my containers. Or I think one of the services here is, reusable containers. So I could, outside of Quarkus, tell it to, hey, I actually want you to reuse that Postgres instance, and it would.
Yeah. So there are two different things. So the freezing containers would just prevent the shutdown. So it's probably would act more like a breakpoint, freezing the operation, allowing you a chance to debug. And the enable reusable containers, it's a property in combination with some API configuration on the containers. You can say with reuse equals true, like with reuse true call to configure. And then if you have the environment that opts in for reusing containers, not to, like, if you're running on the like a beefy CI machines, not to like spoil them with like Kafkas from previous test runs or databases. Environment consents, and the code says that I want to reuse the containers, and then they opt out of cleanup and they can run forever, and you can reconnect to them if you didn't change the configuration of the container.
Yep. And so for anybody who's interested in like the demo that we did, these applications that are actually, it's fully written in a full suite of tests out on my GitHub. There's, if you go into like source test, Java, there's actually tests for everything in here, like for all the APIs and all the endpoints, and it's kept up to date. So anybody who's looking for these sample applications, if they want to play around with it, by all means, I don't know that I can post. Uth, this may be something that you may have to do as the host here, post it into the chat, if anybody can do that.
If you're watching this and you're looking for the task tracking system, consider Quarkus to do apps.
Yeah, and then I could come back in here into my where'd my REST endpoint go resource, and I could say, now I tweeted, I could add my Twitter client here. I could say private Twitter client, inject it through my constructor, and then down here I can say, Twitter client send tweet, new tweet, entity title, and now it'll actually tweet it out to Twitter. Granted, I don't have an actual account key or anything with Twitter, so if I tried this in my UI, it would fail because I haven't configured security. We've kind of dumbed it down for this example.
In production, you would need probably to configure the actual
API
Twitter and Twitter
that.
endpoint and your username and like maybe API key and so on. But well, I feel development is so much better than production. Faster to iterate, less responsibility.
Yep. That's
no,
right.
production. We love production as well. But this is an example, so that is left as an exercise to reader.
Yep. Yeah, I think that's about all we have. I think we got are there any questions from anybody? Kind of now is your chance. I don't think we have, unless you have something else you want to talk. I think that's about all we've got.
Yeah, I think it was a. Sorry,
I've got a question. Once I found the mute button, With local development using test containers, what do you actually need on your machine to actually get it to work? Does it work with Docker, Podman?
Yeah. So for test containers, what you need to have for the test to have a compatible Docker environment, and that means a Docker environment that supports the Docker APIs. Test containers doesn't use the command line like invocations like Docker run something, but it sends the API calls to the Docker daemon, right? So that needs to be compatible. It could be your Docker desktop. It could be your Podman. It could be like, I guess, Podman desktop application. You can configure test containers via property files to use a particular Docker runtime. If you are using test containers desktop, you can click the checkbox because if we use Docker context to list the available Docker runtimes for you to simplify that. But people are running all kinds of combinations with all kinds of Docker runtimes. If you have challenges with the particular setup, please, I think the best way to resolve is to join the test containers Slack workspace, so it's slack.testcontainers.org, where you can, well, the team is there, the test containers team is there, but also there are like a few thousand community members, and most likely there are people who run a similar setup or at least the same set of technologies, and they can help you figure out the details, right? So like maybe it could be your CI runs a more involved setup with, I don't know, Docker in Docker, or Docker as a sidecar in your OpenShift environment to run the test containers tests. You can, of course, easily run it with test containers desktop and test containers cloud. Then you don't need to have a local runtime, and it's a user space application if you are concerned about running containers locally or giving it too many privileges. But yeah, a compatible thing would work.
Okay, that sounds good. And one question for Eric as well, because I always like dropping questions on him as well. If you're using, for example, the Quarkus dev mode and you're using test containers, is there any capacity within Quarkus to detect the amount of time it takes for the container to actually load? So I'm talking about, when I'm doing development locally on my machine, I access, for example, key.io or Docker Hub or whatever. And I often get a bit of a lag, especially if I'm downloading Starfield or something like that. Is there some kind of capacity within the Quarkus dev mode to detect the time it takes, or does it fail because it can't? It starts the process before the container is loaded.
So under the covers, it's using the test containers. I know test containers itself, if it can't, and I don't know what the timeout is, but there is a timeout if it can't pull or it can't recognize that a container has started in a whatever set time amount is. I think that's dependent on the technology. Like Kafka typically takes a whole lot longer than a database to start up. So each one is configured a little bit different. And that's part of the abstraction, is what to look for to know that it's up and healthy and whatnot. But Quarkus itself, I shut everything down, but in the dev UI, there's a, I forget which box it's called, but it's one of for like build items, and you can actually look at what the Quarkus do at build time, which is part of the dev mode, and see, did this at this time and this at this time and this at this time, and it might, I can't say for sure what exactly is in there, but it might be in there, like when did it start trying and when did it stop. It would also be in the startup log as well, and if it failed, it would fail with an error message and whatnot.
Can I share my screen for a sec? I want just to maybe provide a little bit more context on the test container side of things. So
can you make it a little bigger, Oleg?
Yeah. Sorry about that. So containers are just a part of this, right? Like you want, as you mentioned, the application and container to also start. And it can take a little bit of time, depending on the actual service and depending on the amount of resources you give to your Docker runtime, right? If you limit yourself to like one CPU and like a gigabyte of RAM, and you're trying to run something on the heavier side, like, I don't know, Elasticsearch cluster or DB2, then you will have to wait until everything is initialized. So test containers exposes this abstraction called wait strategies, and there is also a separate startup strategies which is you can programmatically configure what does it mean for the container to be ready. And then the default timeout, I think, if you don't specify anything, is 60 seconds. So if I just use the generic container, it's going to try it for a minute and then fail if not. But you can specify, for example, that your container is ready when it responds to a certain port, or the container is ready when you can run a command. Or very typical, what we use is container is ready when we see a certain line in the log file, the container. So Postgres starts and says, Postgres is ready. And then we know that the container is ready. There are, of course, the timeouts on top of that. So if it doesn't start like in 10 minutes or something, it's by default fails. But you can programmatically configure that. And most of the modules, I think actually all of the modules, configure some sort of a waiting strategy that makes sense for that particular technology. So which is how those go through the abstractions to the Quarkus dev services and then to your application. And if you want a particular specific thing for the services that you run, you can, well, the same way we wrote the lifecycle manager for WireMock. Eric didn't show that because WireMock container starts pretty fast, but we can also, it was an abstraction, right? So there is a waiting strategy inside. But you can specify and override that and say, like, I would like to start my container, and like whatever it does, like it can take its time up to like 5 minutes and until a particular endpoint is ready. So that's how we control that. And then in the logs, we do write how much time it took to start the container. That includes pulling the image from the registry if you needed to do that. So you can look at those log lines. I don't think there is currently a better way to look at that. I think it could be maybe one of the features for the desktop application to show on the dashboard. But those are the building blocks, right? Waiting strategies and log files.
Cool. That sounds good. I'm just going to turn off the screen a second. So yeah, I think we're coming up to the hour. So thanks for that, guys. That was really useful. We're going to be back in a month with something else. I think it's to do with JFrog, whatever JFrog is. But again, thanks for tuning in, people, and we'll see you soon.
Yep, thanks for having us.
Thank you.